All right, so in this video, we're going to get started talking about factoring. Factoring is the process of splitting up or breaking up, I think there's two T's, splitting up an expression into smaller expressions. It's a tool we'll use to simplify and solve equations. So this is really, factoring is going to come up over and over and over again. So if you don't already know how to factor, please really work on this. I'll provide some more resources, so this is going to be a really important tool for us. All right, so greatest common factors, and this is going to be pretty much our first step for factoring the whole time, is finding the greatest common factor. So to find the greatest common factor, or GCF, you need to find the largest factor that all terms in the expressions share. So we're going to think about this in two parts. We're going to think about the number part, the coefficient, and this will apply to the constants as well. And we'll also think about the variable part. So if we're looking at this first example, 6w plus 39, when we look at the numbers that we've got 6 and 39. So if we're asking ourselves, what is the largest number that both of these share? It's a 3, right? So there you can pull a 3 out of 6, and you can pull a 3 out of 39. And if you aren't sure, then you can look at the numbers that you maybe know more about. 6, you know, okay, so that's going to be 1, 2, 3, and 6. And so you could try to divide 39 by those, and we're looking for the greatest of them. So you start 39 divided by 6. That's not going to give you a whole number. Then you do 39 divided by 3. Okay, great. That means it's 3. All right, and then we look at the variable parts. And we have a W here, but we don't have a W over here. So that means that's not going to be part of our GCF. Once we know our GCF, it's almost like we're dividing by it, but we aren't really dividing. We're just pulling it out in front of our expression. So we're going to do 6w divided by 3. We just divide those numbers. 6 over 3 gives us a 2. And when that w is still left there, and then 39 divided by 3 gives us a 13 and not much else. And we pull that GCF out in front, and then what's left over. So it's always going to, after you factor out a GCF, it's always going to take this form where it's GCF and then what's left over. And for now, this is all we're doing. We'll see that we're going to be working on, we're gonna have to factor in this like leftover part as well. But for now, we're just pulling out that GCF. So we're good. This is it. All right, let's try another one. So if we're looking at 15x plus 25xy, first, again, we start with that number portion, 15 and 25. We ask ourselves, what is the largest number that these two things have in common? And it's a 5, right? So 15 and 25 are both divisible by 5. So we'll pull that out in front. And then we look at that variable portion. So we're looking at the x and the xy. And what is the largest thing that these have in common? Well, just an x, right? They don't both have this y, so we can't pull it out. We can only pull out that x. And then again, it's like we're dividing. So we're going to divide by that 5x. And let's see what's left over. So 15 divided by 5x, so 15 divided by 5 leaves us with 3. And then the x divided by x cancels out. That's just going to go away. So it's just going to be the 3. And then for our next term, 25 divided by 5 leaves us with 5. And then the xy divided by x leaves us just with the y. The x's cancel out, so we're left just with the y. And so we factored out our GCF. And you'll notice if you were to distribute this 5x back through, multiply it through these parentheses, then you should get back to where we started. If you aren't familiar with the distributive property, we'll be covering that in class soon. So, yeah, we'll get to that very soon. Okay. All right, and then our last one, 4t cubed minus 7t squared plus t. So we're going to start with that number portion. 4, -7, and we've got a 1 there. And so there's nothing that all of these share other than a 1. And if it's just a 1, we don't need to write it. So there's not going to be a number portion of these. 4 and 7 just don't get along very well. And neither does the 1 for that matter. But then when we look at this variable portion, t cubed, that's t times t. So there's 3 t's in this part, 2 t's here and 1 here. So the largest thing they share in common is just that 1 t. And so it's gonna be like we're dividing a t out of this one. So 4t cubed, that first term divided by t, one of those t's cancel out, and that leaves us with just 2 t's instead of all 3. So that's going to be 4t squared. And then 7t squared divided by t. One of those t's cancel out. There's 2 of them here. One of them cancels out. So we'll be left with just 1. So that -7, it stays the same, but we just have 1t now. And then plus t over t, those cancel, but we have to keep that 1 that's in front of it, that invisible 1. If everything cancels, we still need that 1 there. If you start with 3 terms, then factoring out the GCF should not change how many terms you have in that leftover portion. Here we started with 2. That leftover portion had 2 terms. Here we started with 2. That leftover portion had 2 terms. Here we started with 1, 2, 3 terms. That leftover portion still has 1, 2, 3 terms. Okay, so that's factoring out the GCF. Let's work on factoring quadratics with a leading coefficient of 1 now. So this is why we discussed what a leading coefficient is. If we have a leading coefficient of 1, that makes things quite a bit easier for us. So we'll cover quadratics in greater depth later, kind of throughout the class. It'll keep coming up. But for now, all we really need to know is that quadratics are expressions or equations with degree 2. So that means that our greatest degree, our greatest exponent on a variable is a 2. And that's what that next sentence said. Before factoring, expressions should be written with the exponents in decreasing order. So like this, x squared plus bx plus c. This b and c are just any old numbers, but our x squared first, and then the x in the middle, and then the constant at the end. And you'll notice here we have that leading coefficient of 1. The x squared, that 2 is our largest exponent found on a variable. And the coefficient in front of it, if you don't have one written, it's an assumed 1. So if we have something that looks like this, we can find 2 numbers, m and n, where m times n, actually I'll do m plus n first. M plus n is equal to b, is equal to that middle amount, and m times n is equal to c. So they should add to the middle number and multiply to the last number. And then we can write the factored form. If we find these 2 numbers, we can write the factored form x plus m times x plus n. It's going to be 2 sets of parentheses breaking up that x squared. All right, so factor the following expressions. If we have x squared plus 5x plus 6, then sometimes it's helpful first to label your b and your c, and we can do something called a product sum chart. So we want 2 numbers that multiply to c We need it to multiply to C, which is 6 in this case. And we want it to add to 5. And we'd want to keep those signs with it, but since they're both positive, we don't have any issues with this one. So if we just start thinking about numbers that multiply to 6, we could say 1 times 6, but then 1 times 6, that doesn't give us 5, right? So 1 plus 6 gives us 7, which is not equal to 5. So that means that one isn't going to work. 2 times 3 multiplies to give us 6. 2 plus 3, 2, I'm getting ahead of myself here. 2 plus 3 adds to give us 5. So that means 2 and 3 are going to be our numbers here. So we can split this up into x, and then our numbers here are 2 and 3, positive 2 and positive 3, so x plus 2 and x plus 3. And we have factored this expression. And remember, this only works because we have that leading coefficient of 1. All right, so again, we've got x squared minus 9x plus 20. So we have that leading coefficient of 1. So we can look at our b and our c. We need two numbers that multiply to give us positive 20 and add together to give us negative 9. All right, and we can start thinking about numbers that multiply to 20. How about 1 times 20? But that adds 1 plus 20, gives us 21. We could have 2 times 10, but 2 plus 10 gives us 12, so that's not it. How about 4 times 5? But 4 plus 5 gives us positive 9. Ooh, once you have the opposite of what you need, if you get the right thing here, but it's the wrong sign, so you get positive 9 instead of negative 9, that means you need to switch the signs on both of your numbers, negative 4 and negative 5. So those negatives would cancel out and give us positive 20 still. But negative 4 plus negative 5, or in other words, minus 5, gives us negative 9. So that means we have found our numbers. So be sure to look at negatives. And by the way, you don't have to write out everything on this chart every time, right? Sometimes you'll be able to look at this and immediately see negative 4 and negative 5, but know that it's okay to try a few things first. Okay, so if we have x and x, it's always going to be of this form when we have that leading coefficient of 1. So x minus 4 and x minus 5. All right. One more. So if we have x squared minus 2x minus 8, again, we have that leading coefficient of 1, so we can use our little trick here where we just look for two numbers that multiply to the last and add to the middle. So we've got b and c. And these all already came in order. Sometimes you'll have to put them in order a bit. Make sure that your x squared is first, and then your x, and then your constant, so that you don't misidentify b and c. Okay, so we want this to multiply to negative 8 and add to negative 2. All right, so if we're thinking about numbers that multiply to negative 8, if something needs to multiply to a negative, one of the numbers is going to be negative. And maybe we have a bit more intuition. Maybe we're starting to build on this and not have to just write them all out. So maybe at first you think, how about 4 times negative 2? That wouldn't be a terrible guess. 4 times negative 2 does give us negative 8, but then 4 plus negative 2, or in other words, 4 minus 2, gives us positive 2. And just like before, when we get the opposite of what we're looking for, the right number with the wrong sign, it's not going to be that, but we are just going to need to switch the signs on both of our numbers. So we'll switch that to -4 times positive 2. That still gives us -8, but then -4 plus 2 gives us -2. So those are going to be our numbers. That is what we were looking to add up to. And so then now we have x minus 4 plus 2. And be careful with those signs. I'm keeping that sign the same. It does matter which one is negative. All right, and so that is factoring with a leading coefficient of 1. Next up, we'll be getting into factoring by grouping and factoring when we have a leading coefficient other than 1.